All right, you can just stop me if you have a question. So basically, we have a system of equations, and we've got two types of systems of equations. We've got non-homogeneous linear, and we've got homogeneous linear. Homogeneous linear, it looks like this. All the answers are zeros. And then the non-homogeneous linear, we have numbers this side. We don't have only zeros. So we tried, after getting these homogeneous linear equations, we try to solve, and we try to solve them using two methods. One is called Gaussian elimination, and then the other one is called Gauss-Jordan elimination. We use row operations. There's like 3 of them. After doing Gaussian elimination, we get an echelon form, and it's like this. Basically, you have pivot points. We've got pivot points, and then below the pivot points, for example, below this 2, that's the first pivot point, we'll have a 0 and a 0. Then the second pivot point will have a 0. Then the third one, there's no other row, so there's no 0. And then the Gauss-Jordan elimination, you get a reduced echelon form. The difference between the two, in this case, let me just highlight the pivot point. In this case, we've got this pivot point, and then this for 3. But when you look at the first pivot point, we've got zeros below it. And then the second one, we've got a 0 below it, and then a 0 above. And then the third one, because we don't have a row below, we have zeros above it. So basically, just have zeros everywhere with this reduced echelon form. And then, after using these two methods, we use these two methods to get a solution, because we have these equations. We're trying to get x, y, z. The whole aim is to solve, to get solutions. So it gets us into this. This is very important. When it comes to solutions, we can only have 3 sort of solution. We can have 3 scenarios. The first one, we might not have a solution, in which case we say the system isn't consistent. And then we could have one or a unique solution, or we could have many solutions. When we have solutions to the system, we say the system is consistent, right? So I'm just gonna move on to show you. I'm just gonna highlight the solutions. Right. Under solutions, let me just show you the first one, no solution. Imagine we have this matrix. Where's this? 2, minus 2, 6, 10. Right. And got 3, minus 5, 12, minus 6, got 4, got minus 4, we've got 12, we've got 18. And then we do all kinds of row operations, which I won't do right now because I want to show you this important result. 3 5 plus 0 minus 2, 3 minus 21, put a 0, put a 0, put a 0, put a minus 2. And then that's the first one. Then the second scenario, let's get another. We have 1, 1, 2, 9, 2, 4, minus 3, we've got 1, we've got 3, we've got 6, we've got minus 5, and we've got a 0. And then we do all kinds of row operations here using Gaussian's elimination. And then the final result here would be 1, 1, 1, 2, 1, 1, 2, 9, 0, 2, minus 7, minus 17, 0, 0, 1, 3. That's the second type of solution. And then the third solution would be 1 minus 2, 5, 2, minus 2, 4, 10, 3, minus 3, 6, 15. And then we do all kinds of row operations, and then you're gonna get a solution like this: 1 minus 1. Can you reduce the volume, the background volume there? And then we've got 0, 0, 0, 0. We've got 0, 0, 0, 0. So we have like 3 types of solutions. Here we have no solution. I want you to look at the format of this thing. We've got no solution here. We've got one unique solution, right? And then here we have many solutions, or we can call them infinitely many solutions. Finitely many solutions. So the most important thing here when it comes to the solution, with no solution, you can see here that this last number, these are the conditions. You have to be, these are the conditions. 0, you get a 0 here, and then you get a number here. If you get a 0 and you get a number, then there's no solution. With unique solution, you must have a number here, and you must also have a number here. Then those are the conditions for one solution. With many or infinity solution, looking at the last row again, you see here there's a 0, and also here there's a 0. So those are all the conditions. Let me show you a question that will ask for such in an exam situation. In an exam situation, you might get sample. You might get something like this: minus R1 plus R2. This will give me R2. Then same thing with the third row. And this will give me 0. Then minus 1 plus A plus 2 is going to be A plus 1. Minus 1 plus 2 is 1. Minus 1 plus 5 is going to be 4. Then the same thing here, minus 1 plus 1 is going to be 0. Minus 1 plus 7 is going to be 6. Minus 1 plus a plus 1. Just checking things. Yes, minus 1 plus a plus 1. That should give us a. And then minus 1 plus 9. That should give us 8. Right? Then I move on to the next step, the next matrix. In this case, I'm not gonna make this my pivot point because it has a letter. I'm just gonna swap with it with this one because this one is easier. It's easier to play around with. So I'm gonna say 1, 1, 1, 1, then 0. Just gonna swap row 3 and row 2. This is gonna be a. It's gonna be 8, 0, a plus 1, 1, and 4. Then my pivot point in this case would be 6. Now I ask myself the same question. Watch, I need to add these two numbers, 6 plus a plus 1. But how can I do it in such a way that I get a 0? Well, the simplest way is just to multiply the 6 by, in this case, let me just do another extra step. Multiply I'm just going to multiply row 2 by a plus 1, in which case it's going to make this like this, and then same thing here, the same thing here, 8, then this I'm going to multiply by 6, 6, a plus 1, then this is going to be 6, and this is going to be 6 times 4, that's 24, right? Then let me just write this nicely. This is basically 6 a plus 1, right? So now I still have this as my pivot point. I just included the next step. What can I do to make these two numbers cancel each other? Well, I can just say row 2 minus row 3 equal to row 3. In which case, I'm going to be like this: a plus 1 times a plus 1 times 8. And then I'm going to get a 0 here. If I say row 2 minus this, they're the same, they can cancel. I'm going to get a 0. Then if I say a, let me just simplify this. It's going to be a squared plus a. And then I subtract 6, right? So it's going to be a squared plus a minus 6. Then I do the same thing here. Maybe 8a plus 8 minus 24, which will be 8a minus 16, right? Yeah. And then once I reach this step, I'm almost done, because my aim for me to solve this question is almost the same as the last one. I need to find conditions for no solution. One solution, then many solutions. Once I reach this step, my focus is on this. It's on this, right? So for no solution, remember that for no solution, I need this number, a plus a squared plus a minus 6 to be 0. Why this number? So this is a number. If we find a value of a, then it could be one number. While this is a number, basically it's not equal to 0. Because if it's not equal to 0, that means it's equal to some number. Right? Yeah, let me just simplify this. I think it's a plus 3, a minus 2 is equal to 0, and a is equal to minus 3. And a is equal to 2, right? So, but I need 1, right? If I take minus 3 here and I plug it here, I'm gonna get what? I'm gonna get let me just say 8 a minus 2 multiplied to 3. If I plug in minus 3 here, I'm not gonna get a 0, which is good, which is what I want. Let's see what happens if I plug in a 2. If I plug in a 2, I'm gonna get a 0, and that's not what I want. So this is not valid. The condition there, a must be equal to minus 3. A must be equal to minus 3. Because if a is equal to minus 3, I'm gonna get a 0 here, and I'm gonna get a number here. That is not solution. Then I come back and that determines one solution. One solution means here is just gonna write it in this format. A minus 2 equal to is not equal to 0. And I'm gonna also write it in this format. Is not equal to 0. So both of them must not be equal to 0, which means a must not be equal to minus 3, or a is not equal to minus 2. Right. So if a is not, let's say a is equal to 2 minus, sorry, what happened here, plus 2. If a is not equal to minus 3, or a is not equal to 2, right, I'm not gonna get a 0. The same thing here. If I plug any other number besides minus 3 or 2, I'm not gonna get a 0. So it makes our work done. So these are the conditions. I think my screen is just gonna stop now because this thing only gives me 40 minutes. So it's been 40 minutes already. It's just gonna cut. Maybe I can just do the last bit. I'll just share a link now on the Telegram when it stops.